Okay, in section 2, we're going to be talking about the same system of equations, except for now we'll do it algebraically by substitution and elimination. So we're going to look at, if we read this first paragraph together, solutions to a system of linear equations is the intersection of two lines. We talked about that in section 1. But in section 2, we're going to attempt to solve these systems algebraically without the use of a graph. Recall in the system, we were trying to find an ordered pair. So we're looking for that ordered pair, x comma y, that works in all equations. So first we're going to look at substitution. Let's focus on substitution first. There are 4 steps in substitution that we're going to focus on. The first step is to solve one equation for one of the variables. When we solve one of the equations for one of the variables, we're going to substitute that in to the other equation. In step 3, we're going to solve for the first variable that we just substituted, and in step 4, we're going to find the value of the other variable by plugging it back in to one of the original equations. So it might seem a little confusing at first, but let's look at our first example and see how we can apply these 4 steps. So step 1 says solve one equation for one of the variables. Well, step 1 is already done. If we look at both of these, they're actually solved for y. But maybe we can focus on this first one. It's already solved for y. Step 2 says let's substitute that into the other equation. So what we're going to do is we're going to take what y equals in the first equation and substitute that in for y into the second equation. So negative 3x plus 4 equals negative 3x minus 2. We did the substitution there. Step 3, solve the new equation for the first variable. So now we have just x we can solve for. So let's add 3x, 4 equals 6x minus 2, add 2, 6 equals 6x, and divide both sides by 6. You get x equal to 1. So we've got our first value, x equals 1. Step 4 says find the other value by plugging in the solution into one of the original equations. So we're going to take x equals 1 and put it into one of these original equations. It doesn't matter which one. A lot of times I pick the easiest one to work with. Both of these seem fairly easy, but I'm going to pick the second one just because the 3x is positive. Again, it doesn't really matter, but for step 4, let's take y equals 3 times 1 minus 2. Again, I plugged in that into the second equation. Evaluate from there. We have y equals 3 times 1 is 3. 3 minus 2 is 1. So here's our second value. We can write this as an ordered pair. Solution is 1, comma 1. Okay, in this next example, we have no variables solved by themselves right now. So we have to do step 1, get one of these equations for one variable. It looks like this first equation might be easiest to work with. So off to the side, if I solve this for x, or write it in terms of just x equals, I subtract 7y, and I get x equals negative 7y. So that is step 1 done. We rewrote this to look like x equals negative 7y. Now on step 2, we're going to take this and put it in for x. We're going to substitute that value in. So 2 times negative 7y minus 8y equals 22. 2 times negative 7y is negative 14. Y minus 8, y equals 22. Combine these two together, negative 22y equals 22. Divide by negative 22, y equals negative 1. So we found our value for y. Step 4, let's find the value for the other variable by plugging it back into an original equation. So I'm going to look at this y equals negative 1 and see which one of these original equations look easiest. Looks like the first one might. So x plus 7 times negative 1 equals 0. x, well, 7 times negative 1 is negative 7. Then I can add 7 to both sides. X equals 7, which means my solution as an ordered pair, 7 comma negative 1. Looking at the next example, looks like we need to do step 1 again, which is solve one of the variables for one of the equations for one of the variables. This second equation looks like it might be easiest to solve for x. So let's go ahead and do that. So off to the side, if I just use that second equation to rewrite it in terms of x, or solve it for x, I'm going to add 6y to work on getting x by itself. 6y plus 4. But that is still negative x. So what I need to do is divide everything by a negative 1 to make that positive x. So I get x equals negative 6y minus 4. That is the rewritten equation for that second value, that second equation. Let's do the substitution. Negative 6y minus 4 needs to go into the other equation for x. We need to plug that in. So we have 6 times negative 6y minus 4 minus 12y equals 24. We just need to do the algebra from here to solve for y. So I have something I should distribute. Let's do that. Negative 36y minus 24 minus 12y equals 24. Let me add 24 to both sides, as well as combine these two y's. So I get negative 48y equals 48. Divide both sides by negative 48, and I get y equals negative 1. So from here, the last thing we have to do, remember, in step 4, is to take this y equals negative 1 and plug it in to one of the original equations. It looks like the second one might be easier, so let me just do that and plug in negative 1 for y. Simplify and solve. Negative 6 times negative 1 is positive 6. Subtract 6. Negative x equals negative 2. So I'm going to divide through by negative 1 to give me x is 2. Final value, 2 comma negative 1. Okay, and the last example we have for substitution, let's get one of these variables in one of the equations solved for by itself. So I'm going to look at this first one and say, let's get this so y is by itself, which means I'm going to subtract the 1/2 x. I'm going to get negative y equals negative 1/2 x plus 3. Divide everything by negative 1 because there's a negative y, and then I get positive y equals 1/2 x minus 3. So that's the new form of that first equation. Step 2 says I take what I just solved for and I plug it into the other equation. So y gets substituted. We're going to say 6x plus 6 times 1/2 x minus 3 equals 0. Simplify and solve from here. Distribute that 6 to both terms. 6x plus 3x minus 18 equals 0. Combine like terms. 9x minus 18 equals 0. And then solve the rest of this by adding 18 and dividing by 9. So you get a value of x is 2. Again, our last step is to go back to the original equation, take x equals 2, and plug it in. It really doesn't matter which one again, but I'll go for the first one because I know when I plug in 2 for x, 1/2 times 2 just gives me 1. So that's pretty easy to work with. Subtract the 1, negative y equals 2 divided by negative 1, y equals negative 2. So as an ordered pair, my solution is 2, comma, negative 2. And just as a reminder, focusing on this statement right here, just like we talked about in section 1, you can always check these answers by plugging the x and the y's back in to make sure they're true statements. So we can always know if we got these right after we've solved them. And looking at the second part of solving these systems of equations, sometimes when you notice we were doing substitution, it can be difficult. It takes a little bit of time to do substitution, especially with fractions, or if we need to do a lot of rewriting in step 1 of substitution, it can take a little bit. So there's a second method we're going to talk about, and that's solving by elimination. So the method's called elimination, and there's 5 steps here, but I think you'll notice in some of these equations, it's really quick and easy to do elimination compared to substitution. So with step 1, we're going to make sure to write every equation in standard form. In other words, the x term, then the y term, and then equals our constant. In step 2, we're going to multiply an equation by a non-zero number, so any number that's non-zero, so that the coefficient of one of the variables in one of the equation is opposite of the coefficient in the second equation. And you'll see what we mean when we get into the examples. Step 3, we're going to add the equations down. Step 4, we're going to find the value of one of the variables. And step 5, we're going to plug that back in to solve for the other value. So let's see what that looks like in action here. I'm going to leave those steps up top as we look at the first one. So step 1, for this first example, rewrite each equation in standard form. So we need an x, then a y, then a constant. So that one's good. This one's also good. It has x, then y, then equals a constant. Step 2, multiply each equation by a non-zero number so that the coefficients of one is the opposite of the coefficients of another. So let's take a look. If I focus on the y values here, we see one y value is negative 3y. The other is positive y. I want those to be opposite numbers. So I'm going to multiply this second equation by a value of 3. When I do that, let me write that off to the side. I get 6x plus 3y equals negative 24. I didn't change this equation. As long as I multiply everything by the same values on the left and the right, it's still the same equation, but now I'm going to copy the top one over as well and not change it at all. We notice that the y values are opposites. One's positive and one's negative. Step 3, let's add these equations down. So we're going to add them. 4x plus 6x gives me 10x. Negative 3y plus 3y eliminates. That's why it's called the elimination method. 4 plus a negative 24 gives me negative 20. Now this is really easy to solve for. I can divide both sides by 10. X is negative 2. Step 5 then is exactly like the last step on substitution. We need to take x is negative 2, go back to one of the original equations, and plug it in. So let me do the second one because it has a little bit smaller numbers. All the way back to the original equation, I'm going to plug in x is negative 2. 2 times negative 2 is negative 4. And then add 4 to both sides. And you get y is negative 4. As an ordered pair, negative 2, comma, negative 4. Okay, looking at the second example here, step 1 says we need to write everything in standard form. So instead of x and y, we have m and n. This first one is in standard form. The second one needs adjusted a little bit. What I need to do to the second one is add 2n to both sides. So it looks like 3m plus 2n equals 30. The top one we said doesn't need any work done. Now they're all lined up, m's, then n's, and then equals constants. So we need to look at any variable, either an m or an n, that we can get opposites. It looks like n is going to be that variable. So if I focus on n, this bottom one is plus 2n, so the top one needs to be minus 2n. That means I should multiply it by 2. Let me rewrite this. After everything is multiplied by 2, here's what I get. The bottom stays the same, because then we get opposite signs for the ends. Next step, add down. 4m plus 3m is 7m. Elimination of the ends, which is good. We always want that. Negative 2 plus 30 is 28. Solve for m. Divide 7. Whoops, that's a 7. M equals 4. So we've got our m value. Remember the last step, go back to an original equation. So the first equations, plug in m equals 4. I'm going to go for the first equation. Simplify, well, 2 and 4 gives me 8. Subtract 8. And then divide through by a negative 1. Ordered pair would be 4, 9. Looking at our last example for elimination, again, step 1, let's make sure it's in standard form. This one has an x and a y, then a constant. Same with this one. So step 1 is good. We don't need to mess with that. Step 2, we want opposite variables. So we need to look at multiplying one of these equations. If I look at the x values on these two, one is a 2 and one is a 1. So I can multiply this first equation by negative 2, and we'll get opposite signs. Negative 2x minus 4y equals negative 8. I didn't multiply the second one. Next step, add down, and we do get our elimination. And then negative 7y, negative 8 and 1 is negative 7. Divide by negative 7 to solve for y. You get y equals 1. The last step, take your y equals 1 and find an original equation to plug it into. I might go with the first one because it's all positive. X plus 2 times 1 equals 4. X plus 2 equals 4. Subtract 2 from both sides, and x equals 2. So as an ordered pair, our solution is 2, 1. So make sure you use these notes on substitution and elimination to do your section 2 assignment. And that is it.